Welcome back to Thursdays with me. Today is November 17th, and we're going to be doing some quant today with exponents and primes. So let's do it. We just went over the rules and all that kind of stuff. So just to show you this again, these problems are all from the free gmatprep software, which is copyright GMAT. Okay. Let's do problem. There you go. Remember to pick multiple choice answers from here. Please do not answer questions in the chat box. Give it a shot. All right, most of you have answered this one. Should be kind of quick. I mean, don't remember not to think that 2 minutes is some sort of meaningful amount of time for every question. That's one thing that people get into thinking, which is really not a good way to be thinking. Like, they think that literally every question on this test they should be answering in like 2 minutes. This kind of question, there's not really a lot happening here. So this is not the kind of question that should take you that long, is the point. Like 2 minutes is the average time. But if you look at this question with your eyes, it should be pretty clear that this problem is going to take less than the average time. So, but okay, let's talk about it. If you don't remember the way this test works, if you don't have a guess, you should make one. People are kind of all over the place with this. Like here's our current answer profile. Most popular choices that people are picking are A and C, but people are kind of all over the place. So if you don't have a guess, pick a guess. Okay, let's talk about it. So yeah, if you were in like 5th grade, which if you're not in the US, then that's like maybe 11 years old, how would you do this problem? Because you could do it. You could totally do this problem if you were 10 or 11 years old. You could just work out the number. Graph, I mean, I'm not sure what you mean by a graph, but maybe, depending on exactly what you mean by that. But yeah, if you were like 10 or 11 years old, you could just start writing. Yeah, you couldn't really count it on your fingers, but you can just do the arithmetic. Oh yeah, you can. I mean, okay. I mean, because the first few powers of 2 are, I mean, you know, this is 4. This is 2 times 4 is 8, 16, 32, 64, 128. And then once they get bigger like that, you can just start estimating them. I mean, if you're fast enough to just work it out, you can work it out. But 128 is pretty close to 125. So 2 times that is just really close to 250. And then, so 2 to the 9th is another 2 times approximately 250. 2 to the 10th is about 1,000. And I mean, guys, look how freaking big these numbers are now. I mean, a lot of people pick C. I mean, in fact, as many people pick C as the correct answer, and then we also have people picking D and E. But I mean, you know, look at these numbers. These numbers aren't that big. I mean, these numbers are nowhere close to. I mean, because like 2 to the 16th is going to be 1,000 times 2 is 6 more times. So that's going to be like between 50 and 100,000. So if you just do these approximate numerical values, it becomes really obvious that C, D, and E are way too big. I mean, there's no point in even trying to estimate these. Give me a smiley face if that makes sense. So there's just no way. There's just no way. So it's, I mean, you know, we can just approximate this stuff, right? I mean, these first few terms are so small that they almost don't even matter. So like 250 approximately plus 1, like these two together, these two terms right here are about another 200. So those two are. And then the rest of these are really small numbers. So about 250 plus about 200 plus a bunch of small numbers. I mean, it's definitely not going to be anywhere close to 1,000. So we're done. So I mean, in other words, literally nobody should ever get this problem wrong. Because assuming you can multiply by 2 over and over again, you can get this problem right. Because you can just multiply by 2 over and over again. So, yep. I mean, if you got this problem wrong, what that means is one of two things happened. Like either you just never thought to even do the arithmetic, which means that you're not really thinking of these as numbers. You're kind of thinking of them as symbols that don't really mean anything. Like you're just kind of trying to push around symbols according to totally arbitrary rules. Which, admittedly, sometimes algebra can get like that. I mean, when you're doing weird enough algebra, it can seem like you're just using meaningless rules to push around meaningless things. But this is not weirdo algebra, guys. These are numbers. So, like, don't forget that these are numbers with numerical value. But so that's one possibility, right? Like, if you didn't do this, if you got this problem wrong, then one of two things is true. Either you were thinking of these as just random symbols instead of numbers, and so you didn't even think about that. Or the other thing is you like talked yourself out of doing this sort of solution. Because this, I've heard this too. Like I've heard students actually say, "Oh, I thought about doing arithmetic, but I thought it would take like 5 or 10 minutes." Well, no. This doesn't take anywhere near that long. I mean, people are very bad at estimating how long things will take, but a lot of people will literally talk themselves out of this kind of thing, and it's weird because the people who do that, for the most part, are people who have no other method of solution in mind. You know, because if you had 2 or 3 different things that you could try, and you were like, okay, I don't want to do this because I could do this other thing instead, then that's fine. That's just like intelligent decision making. But if this is the only thing you can think, then you should just do it. I mean, because there are a lot of these problems that you can just do arithmetic. Be surprised. So, in other words, if you got this problem wrong, you should kind of feel sort of bad about that. But don't let it happen again, is the point. Okay, any questions about this particular method? We're going to look at this problem in a bunch of other ways too, but any questions about this method, which is absolutely a method of solution, like just literally adding numbers together like you're 10 years old again, is totally a thing. Any questions? Okay. And I mean, you'd be surprised how often it works. I mean, that's kind of the point of this test. I mean, one of the stated objectives of the people who make the GMAT is to create a test where proficiency in like mathematics doesn't really give you too much of an advantage. And so they do throw in a lot of problems like this one, where, hold on just a second, please, sorry. All right, sorry about that. That was actually a pretty urgent call that I had to take. Okay. Let's look at other ways of solving this. But the people who write this test actually have the explicit objective of creating a test that doesn't really advantage people who have like mad math skills, so to speak. So let's take a look at other ways of solving this. So, I mean, another thing like this, one thing about this test is the problems on this test are not super labor intensive. So, like anything that has this many steps to it, like really if there's any problem that involves the same sort of thing for more than 1 or 2 steps, does that make you guys think anything? Very generally speaking. Like here, there is a pattern that continues for at least 8 steps. Does that make you think you could, what does that make you think? I don't know what GP stands for. Thinking much more generally, I don't actually know what that is, but you definitely don't need any fancy words like that. I mean, where I'm going with this is if there's this much repetition, you should be able to just recognize a pattern step by step. So, I mean, in other words, if you just look at that, so this is the thing, and then let's see what happens if we just do the steps one by one. So let me just copy and paste that a bunch of times. Okay. So when you have things like this, because the point is that there's not going to be any, I don't know what geometric progression means, but if that's one of those like formulas, you're definitely not going to do formulas. Like if there's one thing this test is pretty much all about not requiring, it's stuff like memorized formulas. I mean, they really do not want people to need things like that. That's a prime objective of this test. So let's take a look. Let's take a look at these step by step, and let's see what happens. Okay, what's 2 plus 2? You know what that is, 4. Which, by the way, is the same as 2 squared. What's 2 plus 2 plus 2 squared? 8. Aha, that's 2 to the 3. Well, if you add the 2 to the 3 term, you get 16, which is 2 to the 4th. If you add the 2 to the 4th term, you get 32, which is 2 to the 5th. I mean, it's not very hard to see what the pattern is here. right? Like if you just look at the sum is just whatever the 1 power greater than the last term was. Add them up to 2 to the 3rd, you get 2 to the 4th. Add them up to 2 to the 4th, you get 2 to the 5th. So you know it's going to happen, right? This is going to be 2 to the 6th. And this is going to be 2 to the 7th, etc. So this is going to be 2 to the 9th, same sort of pattern, because it ends with the 8th. So pattern recognition is the big thing here too. And the point is that you should pretty much immediately know that you will be able to do pattern recognition. I mean, this is not, there's not going to be anything special about the number of terms that are here. Like, you know, whatever behavior this has stopping at 2 to the 8th, it's going to do the same thing, stopping earlier or later. So just keep that in mind. Everybody understands? Smiley face if this makes sense. So this is the other important takeaway here is you should know that pattern recognition is going to be possible just based on the sheer number of steps that are in the situation. Okay. Any other questions about this? If not, let's move on to something new. Let's do this one. Let's see if you guys learned anything from that. You know where the multiple choice answers are. Multiple choice answers are here. Okay, we don't really use the hand raising thing here, Kevin. If you have a question, you can just put it in the chat box. So give this question a shot, and I'll give you a little bit of time to do that. Okay, you should be just about done with this. You should actually have been done for a while, but if you need to put a guess, then put a guess. I mean, again, if you don't see any sort of pattern recognition here, what should you do? If you don't immediately see something cool to do with exponents or whatever, what should you do? It kind of like, kind of there goes, right? I mean, you should just add the freaking numbers up. I mean, there's only 5 numbers here, and these are not particularly large numbers either, right? I mean, this is very doable in a very short period of time. And I mean, if anybody was like, I don't want to do that, I mean, you really got to reset your priorities, because these are not big numbers, and you know, so 2 to the 5th is 2 times 2 times 2 times 2 times 2, so this is 8, and this is 4, so that's 32, and then 3 times 3 times 3 times 3 times 3, so this is 9, this is also another 9. And this is 3. So this is 81 times 3. 80 times 3 is 240. So this is 243. I mean, these are not big numbers, guys. This is very doable in a short time. So this is 32 plus 32 plus 32 plus 243 plus 243. So, well, I mean, how big is that? This is 3 times 243. So that's about, what? It's like 3 times 240 is 720. That's 7.9. And this is 64. So that is 793. So it's about 800, right? There, 800-ish. Then you have these answer choices. I mean, the other mistake that people make when they do these kinds of approaches is they calculate everything. I mean, you don't need to calculate everything. Like, what are you only, like, what's the only purpose of doing these pieces of arithmetic? Like, do you care what 4 to the 5th plus 9 to the 5th is? Or what's all that we care about there? You just care whether or not it equals this, you know? Right? I mean, in other words, don't make the mistake. A lot of people just sort of go on autopilot and they actually calculate out the values of all 5 answer choices. But I mean, don't do that. I mean, the point here is just to see whether these are equal to 793 or not. So that's all you care about there. Are these equal to 793? I mean, 5 to the 6th is going to be something that ends with a 5. Not to mention it's going to be way too big. So, but this is 5 times 5 times 5 times 5 all the time is going to just end with a 5. So that's incorrect. I mean, 13 to the 5th is choice B. I mean, guys, that's a really big number. I mean, you might know already that 13 times 13 is 169. So this is 169 times another 169 times 13. So this is going to be way, 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 way more than 793. It's going to be like a 6-digit number. So no way. And you could also realize that 10 to the 5th is 100,000, and this is bigger than that. So you could also do that. That works too, 10 to the 5th. 2 to the 6th plus 3 to the 6th. I mean, well, so the 2 to the 5th is 32. So 2 to the 6th is 64. And this is 3 to the 5th, so 3 to the 6th is another 3 times that. So there you go. That's the right answer. 64 plus 729 is 64 plus 729. And then these are also way too big. I mean, 3 to the 8th is 729 times 3 times 2 more 3s. So that's going to be like around 6,000 or 7,000. And 9 to the 5th is 81 times 81 times 9, which is like a 5-digit number. So these are way, way, way too big. In fact, every choice other than the correct answer is like at least 10 times too big. So you don't even need to be terribly accurate here. You can just approximate these things. Give me a smiley face if this makes sense. So again, most of you got this one right, which is good. Although, again, there were still a few people who didn't. If you didn't get this right, priorities, you could just do arithmetic. I mean, you can, of course, there are going to be solutions that are not arithmetic. We can look at that really quickly. Like if you have the non-arithmetic solution, if you have 2 to the 5th plus 2 to the 5th, then this means you have, this is 2 to the 5th. So this is 2 times 2 to the 5th. But 2 is 2 to the 1. So that's why that works out to be 2 to the 6th. So these terms are that term. And the same sort of thing is true here too. If you have these 3 to the 5th, then that's the same kind of reasoning. This is 3 to the 5th plus 3 to the 5th plus 3 to the 5th. So and so that's 3 times 3 to the 5th. And so that's the same thing as 3 to the 1st times 3 to the 5th. And so that's 3 to the 6th. But the thing is that you don't have to do this. That's the point. I mean, in this problem, you can also just do arithmetic. And when you review the problem, you should be, of course, the main point of reviewing problems is to come up with as many ways as you can to solve them. So when you review this problem, you should focus on how else can I do this besides whatever I did the first time. Like if you originally solved this problem by arithmetic, then when you review, this should be your focus. If you originally solved the problem by this sort of method, then when you review, you should be like, I'm going to do this with arithmetic. The point of reviewing is just to have more ways to do things. Any questions? Okay, let's do another one. How about this one? Remember, these are numbers. They are numbers that mean things in the world. And don't forget where your multiple choice answers are found. Give it a shot. Okay, let's talk about it. If you don't have an answer, please pick one. So a couple of people who don't have answers, please pick one from this multiple choice menu, please. Somebody tell me something about choices A, B, and C. Like even if you don't have any idea how the exponents work in this problem, someone tell me a story about those 3 choices. Yeah, they're too small. I mean, like think about these 3 choices. Like if you put in choice C, this is going to end up saying that 2 to the 13th minus 2 to the 11th equals 3 times 2 to the 13th. I mean, that doesn't make any sense. I mean, you can't take a number, subtract something from it, and get 3 times the original number. So, like, this whole thing is less than 2 to the 13th. And this is obviously more than 2 to the 13th. So, that's not going to work. And I mean, choices A and B are even worse. I mean, choices A and B are saying if you take 2 to the 9th or 11 and subtract something from it, then you'll get 3 times 2 to the 15th. I mean, that's definitely not happening. So, meaning that there's no, even if you have no idea how this problem works, these 3 choices are very clearly not right. And there were a handful of people who guessed those choices. I mean, again, it's like I said about that first problem. Where was that problem? This one right here. This happens, right? People get into this frame of mind where these numbers are not even numbers anymore, and they're just thinking about them as stupid symbols that don't even mean anything. I mean, because if you picked either A, B, or C on this problem, that's the frame of mind that you were in. Like, you were thinking about these as symbols that don't even mean anything. Because if you had thought about these as numbers, basically at all, you would definitely have realized that these are impossible. So, I mean, give me a smiley face icon if that makes sense. Okay, for sure, right? Now, between these two, I mean, again, you can just do arithmetic. I mean, because these numbers are not going to be that close to each other, right? So, I mean, 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. I mean, if you have a great memory, you could try to memorize these, but it's not terribly necessary because it's not that hard to just calculate it. This is approximately 125. So then 2 to the 8th is approximately 250. 2 to the 9th is approximately 500. I mean, if the answer choices were close enough together, then you might have to actually calculate these exactly, but they're not. They're not really that close. So 2 to the 11th is approximately 2,000. 2 to the 12th is approximately 4,000. 2 to the 13th is approximately 8,000. And, you know, you can just write these out on your scratch work. 2 to the 14th is approximately 16,000. 2 to the 15th is approximately 32,000. And then we are only going up to 2 to the 17th, right? So this doesn't really take that long. There, that's not very painful. So if you try to plug in choices D and E, I mean, 3 times 2 to the 13th is 3 times approximately 8,000. So this is about 24,000. This is. I mean, choice E is 2 to the 17th minus 2 to the 15th. So that's approximately 128,000 minus 32,000. I mean, this is still almost 100,000. This is like about 4 times too big. So no, D. I mean, if we approximate D, this is approximately, this is 2 to the 15th minus 2 to the 13th. So this is approximately 32,000 minus 8,000. So look at that. That's pretty much exactly what we want. Look at that. Sweet. So no algebra necessary. You can just do arithmetic again, because that's a thing that you can do. Any questions about that? At the very least, nobody should have picked A, B, or C. I mean, those should have been immediately clear that those do not work, because you can't subtract something from a number and get more than you started with. It would be really cool if our bank accounts worked that way, but unfortunately they don't. Like, I have $1,000. I spent $500. Now I have $5,000. Well, that'd be neat. Unfortunately, it's not how life works. So, look, we can talk about the algebra here. Remember that if you did this, then your review should be like the algebra mostly, and if you did algebra, then your review should mostly be this. I mean, you're always trying to review the things that are less automatic for you. But here's the problem. I mean, the main obstacle is figure out how the heck to handle this. So like when you have this kind of exponential expression, if this confuses you, what you should do is you should think about what happens with more familiar looking expressions of the same form. Like, what if I gave you something like this, x to the 7th minus x to the 5th? Like, how can you, what can you do with this? Aha, you can pull out the lower power. So that's going to give you x to the 5th times x to the 2 minus 1. So if you have something like we have here, similarly, if it is at 2 to the x, well, it is 2 to the 7th minus 2 to the 5th. I mean, obviously, you could just make them in numbers, but you could also factor out 2 to the 5th. And it would work out, because it doesn't matter if that's an x or a 2. Right? Give me a smiley face if that makes sense. People tend to be more comfortable with that, but that's only because they've done so much more homework with things like x in these situations as opposed to things like 2. I mean, if you'd worked enough problems with numbers there, you'd be fine with that too. So then the next sort of thing, if it's 2 to the x minus 2 to the x minus 2, the small power is x minus 2. So that you pull out that. And then x, when you take x minus 2 away from x, you get 2. So this is the same thing. So this is actually the same as this. And so that's 2 to the 2 minus 1 is 3. So this is 2 to the x minus 2 times 3. So 2 to the x minus 2 times 3 equals 3 times 2 to the 13th. Because that's this. So the 3's are gone, and you end up just realizing that minus 2 is 13. There you go. Any questions about this? The most important takeaway is that if you get confused by these kinds of expressions, you should think about simpler expressions. So, I mean, there's not really a lot of stuff on this test that's more complicated. Like, they don't give you problems that are more intricate than normal problems. They just give you a lot of problems like this one where you're just not used to seeing these things in this context. Like, you've probably factored out a bunch of exponents before, but you probably just haven't factored them out when they look like that. So this is the same sort of thing, you know. I think people have the same problem with word problems, right? Like, if I make 3, like, if my friend and I, if a friend and I are making wedding invitations or something, and I make like 10 wedding invitations per hour, and she makes like 8 wedding invitations per hour, I think everybody's going to know we make 18 of those together. But as soon as those become like fractions, like if I produce 1/12 of some object per hour and she produces 1/9 of some object per hour, then suddenly people are like, I don't know if I can add those anymore. Because the numbers are just weird, right? People are just, when numbers become fractions instead of whole numbers, they're like, I don't know what to do with this anymore. So that's the same sort of thing. I mean, you want to draw some sort of analogy to more intuitive processes. That's honestly a huge part of when you have difficulty with stuff like this. That's a big part of it. And don't forget that you can just do arithmetic. I mean, this is a thing. This list takes like 20 seconds to make, guys. You should just make it. Maybe 30 seconds. Shouldn't take much longer than that. They do that on purpose, by the way. I mean, they make these things so that you can just calculate them. I mean, if you ever notice, the official problems are never too big for you to calculate stuff. I mean, like, this is not 2 to the 97th power or anything like that. I mean, these powers are pretty much very carefully chosen to be big enough to intimidate people who are easily intimidated, but to be small enough that you can actually do this in a very small amount of time if you just basically shut up and do it. So that's on purpose. I mean, like, same thing with this problem. I mean, this problem contains exactly enough terms that people who are afraid to do things will be afraid to do it. But there are still few enough terms that it is very easy and fast if you just basically shut up and do it. That's the point. They're good at that. So the point is to be very aggressive with trying stuff. Okay, let's see another problem. Let's see. What about this one? Don't forget where the answer choices are located. If you don't have an answer, please pick one. We'll give you like 20 more seconds to do that. All right, let's talk about the problem. Anyways, so this expression is bigger than others, but you can still at least eliminate a couple of answers based on the size of the numbers. Like, the choice that the second largest number of people picked is A. But if you think about the size of the numbers in choice A is not anywhere close to big enough. Like if you think about this would be, if it's A, this makes the right-hand side into 2 times 10 to the 11. So, but the left-hand side is 5 to the 21 times other stuff. I mean, the left-hand side is 5 to the 21 times stuff. If you think about how 5 to the 21 works, and that's 5 times 5 times 5 times 5, etc. I mean, how many pairs of 5s are you going to get out of that? On the left-hand side. Yeah, you're going to get, so there's 21 5s. So if the last one's going to just be left out. But you're going to have 25 times 25 times, etc. You're going to have 10 of these times 5. And then you still have the other stuff, too. Like you still have that stuff. Smiley face if that makes sense. I mean, so if you multiply 10 25s together, guys, I mean, this is only 11 10s. I mean, this is going to be so much bigger than that right-hand side. I mean, this is, not to mention you haven't even accounted for the 4 to the 11th yet. So this is already way, way bigger than the right-hand side with choice A. And that's without even accounting for the 4 to the 11th. So if you actually do use the 4 to the 11th, it's going to be even bigger. So that's not going to work. This one, on the other hand, this one you're going to have to kind of, I mean, what you could do is arithmetic. I mean, you could think about how these 5s and 4s go together. And how many of the 5s can you put the 4s? Well, what can you do with this stuff? I didn't really ask that in very good words, but what could you do here? Yeah, you could, okay, so what are you doing with 5 times 2? What is that? What are you breaking this down into? Okay, so in other words, 10 is made up of 5 and 2. So what would you want to do with 4 if you had the chance? So you could try to make it into a power of 10, but the problem is that getting 10s out of these is not that easy. On the other hand, if you break it down into 5s and 2s, then it's going to definitely work, because there's the point of prime factors is that prime factors are always the same. I mean, if you break a different, because I mean, that's the thing with prime factors. If you break up numbers in ways that don't involve prime factors, then you could break them up in lots of different ways. Like if you have 100, I mean, this could be, you could break this up into 10 times 10, or you could break up into 20 times 5, or 25 times 4, or even like 5 times 5 times 4, or 50 times 2, or 5 times 10 times 2, or 2 times 25 times 2, etc. But there's only one way to break this up into primes. Which is going to be 2 times 2 times 5 times 5. Like, this is the whole point of prime factorizations, is because like what you're looking at here is kind of like, the left-hand side is kind of like if I broke up 100 like this. And the right-hand side is kind of like if I broke up 100 like that. I mean, these are the same number. But the only way to see that would either be to multiply it all back out and get 100, or to keep breaking it down until it is primed. So like these numbers, you could just multiply them out. I mean, this is, 5 times 4 is 100, and so is 5 times 2. But you can't multiply this out. This is too big. So what this problem should be telling you to do is break these things into primes. So let's do that. I mean, 5 to the 21, 5 is already a prime. 4 is not a prime. What do you do with 4? How many? That's 4 to the 11th. So 4 is 2 times 2. So 5 to the 21 times that, 11th. How many 2's is that? Yeah, although, you know what? This is 22 2's. So, and you don't need to memorize exponent rules to do that, because you can just think about writing this out. I mean, if you wrote out 2 times 2 11 times in a row, then there would be 22 2's on your paper. I mean, like if you have this memorized, that's great, but it's not necessary. I mean, you can just think about writing out all those 2's and counting them. I mean, that's a thing. So, and then in terms of this other side, well, in terms of primes with that one, that's a 2, and then that's 5 times 2 to the n. So that's going to be 2 times n number of 5's times n number of more 2's. Let me smiley face if that makes sense. But if you look at what happens here, I mean, the greatest thing about the prime factorizations is that the 5's and the 2's don't play with each other. I mean, that's the whole point of breaking the numbers down into primes, is that like each prime is kind of a separate world of its own. Because like, you can't put 2's together to make 5's. But that's the reason why prime numbers are a thing in the first place, is because you can't combine primes to make other primes. Whereas you can do that with other kinds of numbers. So if you just look at this, if you just look at that and that, I mean, these are the only 5s. That means that you can find what n is, because you're not going to get any 5s from anywhere else. So these are all the 5s. So n must be 21. I mean, if you want an extra reassurance of that, you could also look at the last step. I mean, if you think about writing all this out, the point is that these factorizations have to be the same. Like when you write these out, if you actually wrote out all the 5s and 2s, you would have to have the same number of 5s on each side, and you have to have the same number of 2s on each side. I mean, smiley face, if that makes sense. Especially Jesse, who asked the question. Jesse, does that make sense? Jesse, are you alive? Okay, so like basically that's the deal, right? If you wrote these all out, then if you actually wrote these out, there have to be, you need to end up with the same number of 2s and 5s on each side. Like if you broke out 5 times 5 times 4 and you broke out 5 times 10 times 2, you would end up with 2, 2, 5, and 5 on both sides of that. And that's what happens with primes. Is, you know, don't worry about you. That's kind. But no, the people who are having trouble with this are the people who matter the most in these sessions. So yeah. That is the point of prime factorizations, is it's going to be the same on both sides. Like you're going to end up with exactly the same pieces both times. And so individually, you'll have the same number of 2s and you'll have the same number of 5s. So you can just look at one or the other of those. I mean, meaning you could also look at the 2s if you wanted to. I mean, it would be redundant reasoning, but it would help confirm the answer that you got. Like if you took these 2s and then you took these 2s together, these have to be the same as well. Yeah, so if you look at the 2s separately, it should also work. So like if you have 22 2s on the left, and if you have a 2 times n number of 2s on the right, and they have to be the same number of 2s. So in other words, if you have this, then that has to be 22 2s. So therefore, n has to be 21 because of that additional 1. Give me a smiley face if that makes sense. I mean, the point is that these are separate things. I mean, you're not, the 2s and the 5s do not interact with each other. And that's the point of prime factorizations. Like, that's why you use them, because they break down these things into components that don't interact. So that's the whole point of it. And they don't unless they are primes. That's not true. Like if you had 4s on one side and 2s and 10s on the other side, those numbers do interact with each other, which is why this kind of thing doesn't work until you break them all down into primes. So there you go. And in general, this is the thing. I mean, there are probably other shortcuts you can do. Like if you see a way to pull 10s out of this, then you could probably go that way too. But the point is that primes will always in these kinds of situations, primes will always let you equate the different parts of them. So neat. All right, that is what we've got for today. We don't. It's about 29 after the hour, so we don't have time to do another problem. But there's always next time. The next time is not for at least 3 weeks. I forget what the actual date is. It's December something. So, but go ahead and check the website for the next date. It's going to be at the same time again. It's going to be at this 6 Pacific, 9 Eastern time. There's 2 sessions in 2 consecutive weeks in December. I just don't remember whether they are like the 8th and 15th, maybe something like that. But check it out, and I think you got to sign up individually for each session anyway. So just have a look at it. Thank you, and I will talk to you in about 3 weeks. Good afternoon, good evening.